All right, let's dive in. Today, we're not just looking at a coding problem, we're on a quest. Think of it less like a dry algorithm and more like an epic expedition to find a single, solitary peak element. Let's get started. So, picture this. You're standing at the foot of a mountain range that stretches for 1,000,000 miles. Your job? Find a peak. Any peak. How in the world would you even begin to tackle something like that? Well, that's the heart of the challenge we're unpacking today.
Okay, so before we start climbing, every good adventurer needs to know the rules of the game, right? We need to understand the terrain. So what exactly is a peak?
The definition is almost too simple. A peak is just a point that's higher than the ground immediately to its left and immediately to its right. That's our target. Find any number in a list that's just bigger than the numbers right next to it.
Let's make this real. Look at this first array. The peak is pretty obvious, right? It's 3. Easy. But now, check out the second one. Now we've got 2 peaks. The number 2 is a peak, and so is the number 6. Now here's the crucial part. The challenge says we only have to find any one of them, and that little detail, it turns out to be a massive clue for our strategy.
So when you're faced with a problem like this, what's the first thing that comes to mind? Well, for most of us, it's just start walking, right? Let's call this the long, obvious hike.
The approach is about as straightforward as it gets. You start at one end of the mountain range, you look around. Is this a peak? No? Okay, take one step forward. How about this spot? Is this a peak? Still no? Take another step. You just keep doing this, step by step by step, until you finally find one.
And you can probably already see the problem with that. Sure, it works great if you're trying to find the highest point on a small hill in your backyard, but for our 1,000,000-mile-long mountain range, walking the entire thing step by step would take, well, basically forever. It's just not going to work.
And when I say it's not going to work, that's not just me being dramatic. See, our quest has a catch, a big one. There's a serious deadline that makes our long, obvious hike totally, completely impossible.
And here it is, the rule that changes everything. This little bit of notation, O log n, is just a fancy way of saying impossibly fast. It means you are absolutely forbidden from looking at every single element. You can't take 1,000,000 steps. You have to find a peak by taking just a handful.
So yeah, our simple plan of walking from one end to the other, it's out the window. It's a non-starter. The direct path is a dead end. We have to be clever here. We need a secret shortcut, a way to find a peak without walking the entire range.
So where do we find this amazing shortcut? Well, it all comes down to a really beautiful, simple idea. It's about changing our perspective. Instead of starting from the edge, we're going to get a view from the middle.
This right here, this is the game changer. Forget walking from the start. What if we could just call in a helicopter and drop right into the absolute center of our search area? What could that one single viewpoint tell us?
Okay, so we're in the middle. Now what? All we have to do is look to our right. Just one look. If the ground is sloping up, well, a peak has to be over there somewhere, right? What goes up must eventually come down, so we know for a fact a peak is in that direction. But if the ground to our right is sloping down, well, then a peak is either where we're standing or it's somewhere behind us, to our left. Either way, and this is the magic part, with one single observation, we get to throw away half of the entire mountain range.
And that one simple insight gives us our whole new strategy. It's this awesome loop. First, you jump to the middle of whatever area you're searching. Second, you look at the slope to your right. Third, you chop off the half of the range where you know a peak can't be. And then, you just do it again on the smaller piece that's left. Jump to its middle, look, and cut it in half again. Over and over.
This strategy is, it's genius, right? It's powerful, it's elegant, and it is blazing fast. So now, let's translate our explorer's shortcut into a map that a computer can actually read. Let's look at the code. And there you have it. Seriously, that's it. This short, clean little block of Python, that is our secret map. The entire logic for finding a peak in a mountain range of any size, captured in just these few lines.
Let's decode this map together, line by line. Start and end, those are just the boundaries of the area we're currently looking at. The while loop just says, hey, keep going as long as our area is wider than a single point. Then mid, that's our helicopter dropping us into the middle. Now the big one, the if statement. That's us, standing there, checking the slope to our right. Is it going downhill? If so, we know the peak has to be in the left half, so we update end to shrink our search area. If not, it's going uphill, so the peak must be in the right half, and we update start. The loop keeps doing that, chop, 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 until start and end finally meet at the same spot. And guess what that spot is? That's our peak.
And the payoff for all this cleverness? We did it. We met that impossible deadline. This algorithm runs in O of log n time. Quest completed. But let's put that O of log n into perspective, because this is where it gets truly mind-blowing. Remember our million-mile mountain range? Instead of taking 1,000,000 steps, this algorithm takes around 20. Yeah, you heard me right. 20 carefully chosen questions to find a peak in a dataset of 1,000,000. That is the staggering power of cutting a problem in half.
So you see, the real takeaway here isn't just about a piece of code. It's a way of thinking. It proves that sometimes the most intimidating problems aren't solved by brute force, but by finding that one clever question that just cuts the challenge in half. And that really makes you wonder, doesn't it? What other giant problems out there are just a few clever questions away from a solution?